Hello, everybody. Hope you're having a good day. Today, we're going to be talking about simplifying a radical expression or rational expressions. So, a rational expression is a fraction, right? When you have a numerator and a denominator. And what we're going to do is factor out the greatest common factor between the numerator and denominator. We also want to make sure we understand that the denominator could never be zero because we cannot divide by zero. So there are a few examples right there of rational expressions. Notice they have a numerator and denominator. That's what makes them rational. So all this stuff is in your textbook. You can read through it if you want, but it's just talking about the idea that you can't have zero in your denominator. And this is kind of going back to thinking about the very first chapter where we were finding the greatest common factors. So here's our first two examples here. We just want to pull out the greatest common factor out of the numerator and denominator so we can simplify it. And I'm not going to do factor trees or anything like that. We're just going to look at it and see if we can figure out what is the greatest common factor in this problem. So if you look at 18 and 12, we say, what is the biggest number that divides into both of those? We'd say 6. And then how many A's do we have in common? Well, we have 2 A's. And then we have how many B's? 1 B. And then we don't have any C's in common because there's none in the denominator. So our greatest common factor would be 6A squared B. So that's what we need to divide out of the numerator and denominator. So let's factor those out or divide them out, however you want to look at them. And we would end up with 3b to the 4th c cubed all over 2a squared. Great. So now the next problem here. We want to look at it and say, well, what is the greatest common factor here? Hopefully you already see it. They share a 2x minus 1 because there's 3 on top and one of those on bottom. So 9 and 24, the biggest thing that divides into both of those would be a 3, right? So, well, I shouldn't have an equal sign there, but finding the greatest common factor here. So they have a 3, and then they have 2 x's in common, so x squared, and then one of the 2x minus 1s. So that's what we have to factor out of the numerator and denominator, or think of it as dividing out, however you want to think about it. So let's go ahead and do that. So we divide 9 by 3, and we get 3. X squared by x squared is 1. Now the 2x minus 1, we got to take 1 away, so there's only 2 left. And then 24 divided by 3 is 8, and then we got to take 2 x's away from the 5. That'll leave us with x cubed. And then we take away 2x minus 1, which gets rid of all that in the bottom. So we just have the 8x cubed. All right, so here are 4 examples that we're going to be doing. Now these are a little bit more complicated because we're going to have to do more factoring with the numerator and denominator at each one of these. So let's start off with A. So we want to factor the denominator in A, make it a little bit simpler. So I'm going to put the numerator there. Say, well, the denominator has what? A 3, an A, and a B in common. So we're going to factor out that 3AB. So when we do that, we're just left with an A and a 2. So A plus 2 in the parentheses. So now we could do the greatest common factor method, or we could just look at this and say, well, 3 over 3, that's going to reduce to 1. A squared over A will reduce to an A in the numerator. And then B over B will reduce to 1. So you can just kind of think of it as canceling out, but they're really reducing to 1. So our final answer here would just be A over A plus 2. All right, so let's take a look at b now. So with b, we're going to have to factor. So notice the numerator is a little bit easier to factor because the a value is 1 in this problem. So all we're doing is looking for two numbers that multiply together to give us -6, but add up to be -1. And those two numbers would be -3 and +2. So you could have x minus 3 times x plus 2. Now for the denominator, we're going to have to use the box method. So we're going to start off with our diamond and do a times c, and we would get -6. And then our b value is 5. So we're looking for two numbers that multiply together to give us -6 and add up to be 5, which would be +6 and -1. So now we can draw our box and plug everything in that we need to. So I'm going to put my first term in the bottom left, last term in the top right, and then the two numbers we came up with in the other two diagonals with the x back on it, the variable. So I'm going to go through and factor out the GCFs. So 6x and -2 have a 2 in common. 3x squared and -1x have an x. 3x squared has an x. 3x in common. And then GCF there's 1, but we're right by the negative, so we need to pull that out. So we would have 3x minus 1 times x plus 2 in our denominator. Then we just have to look at it and say, well, what do they have in common? What reduces to 1? Well, the x plus 2 on top and bottom would reduce to 1. So we'd just be left with x minus 3 times 3x minus 1. So let's take a look at C here. So we want to factor out what they have in common in the numerator and denominator. So numerator has an a squared b, so we're left with b squared minus 1. Denominator, we have what? An a squared in common. So if we pull that out, we're left with a squared times b plus 1. So hopefully now we see that the a squared over a squared will reduce to 1. So we can get rid of those. Now that b squared minus 1, hopefully you remember there was something called difference of squares. And that's what that is. That's something squared minus something squared, because 1 squared is 1. So that factors to b plus 1 times b minus 1. And then we still have our b plus 1 in our denominator, and the b plus 1s would reduce to 1. So our final answer, we would just have b times b minus 1. All right, so our numerator there, we got another difference of squares, y squared minus x squared. So that would factor to y plus x times y minus x. Oh, it's ugly y. Let me fix that. All right, in our denominator, they share an x. So let's factor out that x and see what we get. So we're left with x minus y. So notice that y minus x on top and the x minus y, they're like the same but opposites, right? Their signs are different. So what I'm going to do is I'm going to factor a -1 out of the y minus x on the top. I'm going to highlight green here in just a minute. I'm going to factor a -1 out of that because that'll make it x minus y. It'll flip the signs of everything, and then we can reduce that down to 1. So we pull out the negative, and now we've got x minus y. We'll leave that y plus x up there, all over x times x minus y. So now the x minus y's will reduce to 1, and we're left with negative y plus x all over x.